Welcome, everybody, to episode 118 of Axioms on Trial. And today we'll be discussing whether or not evolution is true. Of course, as you guys well know by now, I'm an agnostic atheist. But my co host today is Artemis,
Hi.
who's an omnist. We probably won't get too much into that today, but I'd definitely love to have you back at some point to talk about your religious perspective.
It'll be a long life if we
For
do that.
sure. Yeah. Yeah, I'm really grateful to have you on here and to be able to call you a friend because I feel like
Mhm.
I'm TikTok has been a place where we've made a lot of good connections. And,
Absolutely. And I've
uh,
definitely been able to talk about more about things that I'm really interested in and have knowledge about. So thanks for
yeah,
having me, though.
absolutely. And we're also going to be bringing up uh, Adam and Brendan, who we've had on before a couple months ago. So thank you for coming back. I appreciate your time.
Thanks for welcome. Thanks for bringing us back. Appreciate it.
Yeah, 100%. So let's get into it.
Sure.
I I want to say this sort of to kind of get the conversation going outside of, I'm sure we can talk about the moral conversation next time you come on, but outside of moral concerns that I have about religion, one of the reasons why I am not religious is because from my perception, I see some of the religious perspective to be very much anti-science, and there's almost like a skepticism or dismissal of science as being somehow inherently meant to be anti-religious, like as though science is in the business of trying to debunk theism or Christianity or that sort of thing. And while I do believe that the methodologies are are in conflict, I don't think that there's anything about scientific discovery that necessarily has to be a problem for the idea of theism in general. And so, where I would like to get into is, what is on what grounds do you guys reject evolution? Why do you reject evolution? And is there anything that could change your mind about the way that you understand and view the theory? So maybe we can get right into it. Yeah, like
Yeah.
let us know
Okay.
why
So
you reject it.
I'll let me start with saying I would disagree with anybody who says that like there are people that are Christians that are anti-science. I have encountered those people, and I don't agree with them. I'm not anti-science. Uh, the struggles I have with evolution is not necessarily because of the Bible. The Bible was how I first was okay. Could this align with evolution? Because there are actually a lot of theistic evolutionists. There are many people. One of the biggest ones on YouTube would be like Michael Jones from Inspiring Philosophy. If you know who he is,
I
he's
know
very
it is.
much so a theistic evolutionist. So is Dr. Stephen Meyer, Michael Behe.
That's right.
These are PhD scientists that would agree with a biblical timeline, but interpreted in more of a John Walton fashion as opposed to a Steve Boyd fashion, who are two different Old Testament scholars.
Sure.
Steve Boyd being particularly a Hebraist. So my issue with evolution would actually more so be the scientific evidence. It's not because of the Bible. So after looking at the Bible, I say, okay, well let me take a deeper look into evolution to see why there would be a disagreement if there is a disagreement. And like I'll use terms like micro and macro evolution. What I mean by macro evolution would be your neo-Darwinian evolution. So a family of animal evolving into another one over a long period of time. Microevolution, such as a form of that, would be speciation. We've seen that. We've observed that in a lab. That's undeniable. Like that would be anti-science to say that's not true because it's obvious. But macroevolution, which would be, for example, a single cell organism evolving into all of life as we know it, that I have a problem with because we simply can't observe that. And so to assert that is a bold statement, and the evidence that they use to back that up, I don't. It's not convincing to me. I see a lot more holes than bridges.
So, I guess the first thing I'll say, and I also want to give Artemis, and also Brendan, if you want to add anything about that as well, actually.
I don't. I think that was fine. I fully agree with everything Adam just said there.
Okay,
Yeah.
so in that case, I'll say this. My understanding is that macroevolution is what takes place when microevolution is true. The microevolution is just microevolution on a larger scale, and that speciation, which I think, if I heard you correctly, you said is undeniable, is what is meant and described as macroevolution. Now, Artemis, maybe you can expand on that.
So a lot of times we try to simplify specifically what micro and macro is. A lot of people that say micro's on a small scale, macro's on a large scale. But like when we look at macro, sorry, I was pulling up a lot of different sources here while y'all were chatting. Give me a second here. So for instance, like macro could be an example of pesticide resistance that can happen in insects or on food. A lot of people like to think of it as just speciation, but macroevolution is more than just that. It can be many different things in changes to a specific species over time. It's not just speciation. So I would just add to that.
So can you elaborate? So when you say pesticants, what do you mean exactly?
So pesticide resistance. So
Yeah.
for instance, like I guess another like an analogy to that would be like antibiotic resistant bacteria.
Like H. pylori.
Sort of, yeah.
Or
like
Mirtha.
Yeah, Mirtha. Yeah. So essentially, that over time, like the pesticide is no longer as good as it was previously, and it's not doing as great of a job as making sure that there aren't insects coming after crops. Same thing with like antibiotic-resistant bacteria, which formed from people not taking their antibiotics like they should. So the bacteria over time was able to evolve and to alter aspects of itself so that those antibiotics no longer work on it.
Gotcha. And so my issue with like that as being an example of macroevolution, so for the H. pylori bacteria in particular, a mutation of that allows it to, so when the antibiotic comes and hits the H. pylori, it causes the H. pylori to make a sort of poison, which ends up killing the H. pylori, but the mutated version of it doesn't do that. And so it actually ends up being a benefit in this instance because it allows it to live. But that doesn't change it from being H. pylori. It's still H. pylori. It's just a mutated form. And eventually, that's why they tell you to take your antibiotics for 7 days or whatever the case, rather than just 1 day, is so it can continue to produce enough poison from the other H. pylori that will eventually kill off the mutated form. And so to me, I just don't find that convincing because this happens, we can now draw this bridge.
Well, I wasn't talking about speciation in this specific example. The bacteria that I'm speaking on that would be antibiotic resistant doesn't change species. It's still the same bacteria, but I'm showing that evolution is occurring on that bacteria and altering it on a macro level.
How's that?
Let me comment on something.
Go ahead.
Quick with that. So yeah, that would just be a change on a small level. We do have to be careful of our definition of terms. Because really what the burden of proof is on evolutionists is just to say that there is enough change to, warrant the emergence of all of the creatures we find on the earth, from some, simple starting point like amoeba, so it's big level change, of course. But, this is like a common misunderstanding, but a lot of people think that the Bible entirely rejects all forms of evolution, when actually in young earth creationism, so for everybody who does believe in Noah's flood being a reality, historical reality, that means you actually need speciation in order to get from the species that would have come off of the ark to the variety that we have today. After 4,400 years, you would have to have some speciation.
So I have a question about that specifically with Noah's Ark. So if I'm not mistaken, it has been a short minute, but it was 2 of each animal, if I'm not mistaken, a male and a female, correct?
And 7 pairs of clean animals.
And then 7 pairs of clean animals. Okay, so if we were to look at that mathematically, that would say, so we'd have, so 7 pairs, and then we have the initial pair, so 8 total, 8 pairs, so 4 males and 4 females, if I'm not wrong. So have either of you calculated inbreeding coefficient before?
So-
I have not calculated that. This is interesting.
Okay, so
It was
inbreeding,
just because it's not combined, so it's like a lion and a cat and then a dog. Those are not considered clean animals. Those were just a male and a female. The clean animals were like your hooved animals, ones that you could use for sacrifice and eat and
Okay,
stuff
so-
like that.
so
Those
okay.
were 7.
Okay, so it was just like one lioness and one lion is what you're stating. Like the clean animals were the hooved ones.
Correct.
Okay,
Correct.
so inbreeding coefficients is used today, and you can talk to any dog, any pedigree breeders about this. So inbreeding coefficient is also used on lineages of families. For instance, the Habsburgs are a great example of when inbreeding coefficient comes into play, and we calculate this. So basically, when we came down, I believe it was Charles the Second, his inbreeding coefficient was 0.25, which is exceptionally high in humans, and it led to him being infertile, having many different malformations, just completely, his body broke down, and he died at a young age, unfortunately. And we can see this in animals as well. Genetic variation is exceptionally important with the like for a species to flourish. And so we see bottlenecking actually occur when we don't have genetic variation, when essentially you start to have inbreeding occurring, you start to have like harmful mutations that stick around, you start to have less variation, so you start to see repetition. In fact, a really good example would be the Mexican gray wolf. It's a subspecies of the gray wolf, and they were all taken out of the wild because there's so few of them that they were starting to inbreed with one another, which would lead to the complete extinction of the species. And since we're trying to preserve them at this time, we removed them from that environment so they couldn't do that. And so the reason I have issue with only one male, one female is that they wouldn't have been able to reproduce enough genetic variation for that species to survive.
Okay, so that's really interesting. But correct me if I'm wrong, but in the evolutionary paradigm, if you take the old Earth, history of the Earth, there are a couple mass extinction events, and one of them that could result in an extremely low population of humans, for example, but we don't see any effects of the, bad effects from inbreeding coefficient from that. And so I would ask why, but then I would also like to add this, that if you back up to the first, like if you back up several generations, well, say 100 generations, this works for animals and people. One that you can really see it well is with like dogs. Is the gene code is a lot more complex the farther you go back. Like the wolf's gene code is way more complex than like a Pomeranian's gene code because it's been down selected over time. And so you can't actually breed back from Pomeranian to get to wolf, but you can breed down, which is what happened over thousands of years, from wolf to eventually get to that little cute.
Well, that's selective breeding. There's a reason why, is we bred out those genes. Those genes no longer exist in the genome for Pomeranians. So yes, we can't go backwards.
Yes. Thank you. Okay. So just establishing that in the past, there would have been more complex gene codes. And so, I'll submit that just coming off of the arc, that gene code variation was much greater, like within one animal. So you would have one, say, I'm going to say Panthera, come off the arc type, or, our creationist word for that is kind. You probably have heard this before. So, you get this one big cat come off the arc. And then from that, they have enough genetic variation within them to then, through speciation, create lions, tigers, snow leopards, all Panthera species,
Can I ask you a question?
Yeah.
Just to clarify?
So there you go.
So are you citing this kind of like how not all kids look alike, like from a parent? Is that where your concept of this is coming from?
Of what? Genetic complexity?
Well, you're referencing genetic complexity, and I'm a little kind of confused on what you mean by genetic complexity. Genetics is the complexities of it in reference to like, is a creature more complex than another? I wouldn't necessarily reference like their genome for that, but like from what I'm gathering is like you're saying that like a lion gives birth, and then you're saying that lion somehow held all the genetic variation to give us all of the feline species that we have today.
Not a lion, but some other some other cat that you back up a few more steps. But well, you agreed that if you you can't breed back from Pomeranian to wolf because it has lost that ability to do that.
Well, that was through selective breeding. But I'm just like a little confused of what, like, I don't know. It's kind of a bold claim to say that like one cat species
Well, you're
had enough genetic variation.
but that goes, either worldview has to admit to the same thing. Like
That's
both
why I brought up
worldviews,
mass extinction events.
like they both have the same issue. So that's not really an obstacle.
I don't think that they do though, because I can look at different lineages of different animals that led to specific cat species, feline specifically, and I can go, okay, well, we know through DNA, we know through this that this was the cat that was like before this one and before this one. Like I can look at like dogs, I can go up the line of that, and I can look at like dogs are in the same family. I have to double check this, but I believe it's with foxes. Foxes are
Yes.
in relation as well.
They are.
So that's kind of where I'm a bit confused.
Well, they would all start at that first point, the first of the Canidae family.
The first of the candidate. Sorry, I like lost the video. Give me a second. I've got a bunch of tabs up.
One thing I want to ask too is because
Okay.
this idea of kind, as I often hear it expressed by the
Just think of
creation-
family. It's like the same thing. So like if you look on the taxonomic scale, there's species, I think the next one is genus, and then family. So family would be the equivalent to the Hebrew word. I can't remember the Hebrew word, but which translates to the English word kind.
Aramin.
Aramin. Yeah.
Right, okay.
So, yeah, so that's, I'm sorry, my cat wants it. Give me 2 seconds.
Sure, no
So
problem.
he's a little demanding.
I understand.
Speaking of cats,
Yeah, so I guess I'll jump in here to say this, that I don't think that the Ark could have held 1% of the species
Sorry.
that we see in the world today. This idea that
well, that's not the idea though. That's not, like, no young Earth creationist would claim that.
but you're saying that the animals that were there had enough genetic variations to produce what we see now, and that what I think is very, very not
Well,
what the science is suggesting.
Are you familiar with genetic entropy?
Yes, I am familiar with genetic entropy.
Okay, so
I guess, but it's been debunked. I can pull up the specifications on it if you'd like me to.
genetic entropy has not been debunked.
Okay, so let's get into that then.
Fairly proven.
Okay,
So
so yeah, can you explain what that is?
So the gene gun was invented by Dr. John C. Sanford, and they used this to test the genetic, I guess, effectiveness of individuals today. Of course, we can't go back thousands of years and test their DNA necessarily, but basically what they do is they look at the amount of mutations that you have. You can do this with parents and children that are alive today, and you'll see that the children of the parents have a larger amount of mutations than the parents. And so they use genetic sequencing to go back as far as they can to see how, basically divide how often these genes mutate. And so the guess is about every generation produces 100 genetic mutations. So I have 100 more genetic mutations than my parents do, and so on and so forth. This continues to go up until the first parents. And so that's why 4,000 years ago, from a flood perspective, or 4,500 years ago, these animals and people had far less genetic mutations. So their genes were a lot stronger. They had a lot less issues. Of course, there are also some downsides. Like, for example, I can drink milk because my genes have mutated, and that allows me to be able to drink milk. I'm not sure, cow milk. I'm not sure that you could drink cow milk 2,000 years ago. Or longer than that, before that mutation came into my genetics or my family's genetics. So through entropy, we can calculate how far back these mutations go. And that's actually how we got to the study that's known as the out of Africa theory, which presents the Y chromosome atom and mitochondrial Eve story.
Oh, I have sources on that as well, actually. If I can, give me a second. I have a lot. I have like a lot going on over here. Got computer, iPad, writings, books. just give me a second, because I do have evidence to show that the mitochondrial Eve is actually a tribe from Botswana, and I can list you a specific region and give you the paper on that.
I have the paper right here. If you're looking
Really?
I had a feeling this would come up, so I have the study. I have the more recent study. So you're talking about the 1987 one or the 1990 one?
I'm talking about the recent study.
When?
I'm pulling it. Like I said, I've got like 10 tabs open. Like, y'all got to give me a second.
Yeah, while you get to that, let me just jump in real quick and ask, where would you say that the water went in the context of the flood? Like, where would the water have gone?
It's still here. Yeah. So you have a lot of tectonic activity that then forced continents up, so to speak, and valleys in the ocean lower. And so it actually makes room for all of the water that was there in the flood. You know, like if you take all of the water, I remember reading this recently, in all of the water in Lake Superior, I believe, and you spread it out over the whole U.S. I mean, it would cover the whole continental U.S. up to like, I don't know, like a foot of water if it was all at that level. So it's really a matter of how amplified the terrain is. If you have some terrain has very deep valleys, then water will fill that. But you have water then that would poke through. Sorry. So I would say it's still here.
I have the study pulled up. Is yours on the human origins in a southern African paleo wetland and first migrations?
So I have the newest one I have up is from 2007 from Dr. Robert Carter.
It's not the newest one.
Biogeneticist.
What year is yours?
Mine?
Yeah.
Mine's from 2019.
And what does it say?
So it's on human origins in a southern African paleo wetland and first migrant. So there's about 10 different authors here. But what it goes into is the cradle of modern human life is in Botswana, is what we've seen characteristic 7. This is where we analyze haplogroups like L0 specifically, and it shows migration patterns and things like that happen throughout Africa, as we saw delineation from the L0 haplogroup, which started in specifically give me a second here, I have the name of the area. It said the Kehosan people, and specifically in the Okavango Delta in northern Botswana, below the Zambezi River. And it's actually in reference to the Bantu culture, which is the indigenous people of Africa. And this is also, I'm trying to name these, Lake Makgadikagadi. Is when we would have seen this, because it started breaking, the lake there started breaking up in smaller bodies of water, creating a wetland, which around 200,000 years ago, which is where we saw the migration patterns of L0 haploid group slowly moving. We also see in these like that we look at the lineage of these individuals, and we see that they have inherited the superathletic traits from Denovans with the EPAS1 gene. That's in Tibetans. Sorry, apologies. That's in Tibetans.
Did you say Denovans or Denisovans?
Sorry, Denisovans. Okay. And they have the EPAS1 gene, the Tibetans do, which actually allows them to go to higher altitudes. They got that from them. And then we also have like Neanderthalis. We know that our wisdom teeth came from them, and they were a part of Europe, which is actually a really good example of how we can actually look at certain different groups of people who didn't have any contact with Neanderthals. Specifically, we could look at indigenous populations in North America, also known as Turtle Island, and see that if there's been no European involvement in their lineage, they don't have wisdom teeth. And we're seeing wisdom teeth also be lost as well.
So the point of me bringing up the mitochondrial Eve is simply that all of the mitochondrial DNA that was tested went back to one person.
And that's not true. That's been debunked. I'm treating that to you right now from a more recent study that looks at this.
So what is it? Where does it say it was not?
It comes from a group of people called the Konosayan people.
Khoisan. It's like KHO.
Khoisan. Yeah, sorry. I have pronunciation issues. That's on me.
No worries. They're a very interesting group of people. That's interesting you bring them up.
Yes.
Would they have the most genetic variation then? Is that what you're claiming?
No. I'm just stating that that's the L0 haploid group starting point.
Oh, okay. Well, for the record, everything we've talked about in that paper is all under speciation.
This is about
like that's technically not something that is inconsistent with
But this is
the
modern
young
humans.
Earth.
Where are you getting speciation specifically from? This is
So
Homo
modern
sapiens.
humans, okay.
Yeah.
Well, I'm just saying this is all just discussion of. I mean, the only thing I could see maybe you trying to say is that see they came from Botswana, not Iraq. So therefore, Noah's Ark didn't land there; they landed in Botswana.
I'm just
Or
stating that
you know
it
what I
didn't
mean,
come
like
from one
that.
person. Oh, I'm just stating that it didn't come from one person. It came from a group of people.
Okay, I see where you're going.
So can you read how it would equate to it going to multiple people? Like, can you read that specific part? Because I haven't heard that. If you did, then I'm sorry I missed it.
I can go through the entire paper here if you'd like me to. It's going to take a minute.
Well, because theoretically, it could come from one Botswanan couple, or or Khoisan couple. Like, I mean, I don't know that excludes.
We don't
them.
have any proof of that. That's the issue, though, is that we have proof that it came from these people and that many of these people held the same L0 haploid group, which is what you're referencing for the mitochondrial Eve concept. So we know it came from a group of people in the Khoisan, not just one person.
So, but again, it could have been the first people in that group. Like, I haven't heard anything specifically. Like, in fact, it sounds like the study you're reading is pretty much confirming the 1987, the Y chromosome study, and this one.
It literally speaks on how it's a group in the specific area.
Real quick, while you look into that, I want to ask you guys this question. If the theory of evolution, as it's presented in the modern day, is so anti-scientific, how do you explain that 97% of the scientific community accepts evolution as a dominant theory? Okay, obviously, I'm not saying just because a lot of people believe it makes it true, but what I'm saying is scientific consensus arises from the evidence available and the results of experiments and the results of certain kinds of observations. How could it be the case that evolution as it's expressed is so anti-scientific, and yet 97% of all scientists believe it?
I'm not sure that 97% of
I have it right here.
Like, that's a survey, I'm assuming.
Yeah, so well, some of these things it's even higher, but yeah, there's a number of surveys, and this one specific says this: nearly all, around 97% of the scientific community accepts evolution as a dominant scientific theory of biological diversity. Scientific.
Remember, we do accept evolution on a micro level.
This is regarding
neo-Darwinian evolution.
Sure, but but this is specifically regarding the macro evolution that you were suggesting is inaccurate, an inaccurate description of our reality. From mine, like I was saying earlier, this distinction between micro and macro evolution, as you're expressing it, is not the view held by 97% of the scientists involved in this field. They view macroevolution as being what naturally occurs over a long period of time, when microevolution is true. And so I'm not sure. In fact, I had a question earlier, like we posted. I'm trying to go back to it. I'm trying to find it here. What is the distinguishing factor for macro versus micro in your eyes?
Okay, well, right before I get to that, I mean, you would we would agree actually that there's not just evolution that probably disagrees with the consensus of biologists, but it would also be, we believe there's really lacking evidence of abiogenesis, but allegedly the scientific consensus is in that direction. So, there's actually multiple things that the consensus might have wrong. And of course, this has happened in history too, right? We know that, well, depending on your view of history, vast majority of people used to think the Earth was flat. Science actually,
wait, that's not true. Hold on.
Wait,
that's false. That's false. I'm sorry. I'm going to stop you right there. Most of the world did not believe the Earth was
right
flat.
after I say this.
Okay, I just wanted to correct you because that's not accurate.
Okay, I do want to hear what you're about to say because
no, go ahead. No, it's not accurate.
Go ahead.
Well, you can agree. I mean, I don't know. Do I have to bring up examples? Do you believe that
Yes.
science has always been monolithic through all history?
No.
I mean,
No, but I would
clearly
like examples
Einsteinian
that most of
physics has some disagreement with Newtonian physics, right? So there's always some kind of improvement over time, right?
No, I'd like
Science
evidence that the whole world, that
consensus
most of the
is
world thought that was fine.
broken kind of consistently, right? And there's new findings. Now, we would say that, I mean, we would agree, you know, there is this huge philosophical bias pro evolution in universities, right? To where they don't even accept a lot of work that's being done in questioning evolution, you know, or white papers or anything, right? We would actually agree that exists. And it's more complex. It's actually something kind of complex going on, you know, but it's a good thing. And you've already mentioned this, you know, but scientific consensus doesn't determine truth, but more so evidence does.
And just
so if there's so much consensus, they should have great evidence.
Well,
and let me add some examples of science, you know, of since the consensus being questioned, which ended up, you know, helping us further our advances, especially in like medical science. We used to spray DDT, which is a pesticide, on children. That was something that you had to do for kids to go into school in the 1940s and prior in the US. And it wasn't until somebody questioned settled science that hey, maybe we should stop spraying poison on our children. There's better ways to prevent them from getting attacked by bugs. Like that was a serious issue. We used to put leeches on people to help them get better from a virus because that would help bleed them out. We
still use leeches.
That is not a common form of medical
But we still
practice,
use it.
though.
We still use it.
But in the US?
But I'm confused
Yes.
for a second. So let me address that for a minute, because I think there's a difference between our understanding of reality evolving with new information and building upon better theories. Of course, that's how science operates.
Mm-hmm.
But that is different than saying that this theory is so incorrect, and so it wouldn't be a theory if it was lacking evidence the way that you are claiming. It wouldn't have gotten that far. You're saying, I think it sounds as though you're saying that there is this bias in academia to teach evolution. I think it's the other way around.
Definitely is. There's a law against teaching anything outside of evolution.
Well, now there is, because there was that.
It's in the 1980s.
Yes,
it's 40 years ago.
But it's not because academia itself is like, you know, wants to teach evolution. Because I think from my perspective, the debate between evolution and the creationist worldview that thinks it's debunking evolution, I would say has been resolved. It's not that like the teaching of evolution is because there's some like, and I'm not saying you're saying this, but many people view it this way, some anti-Christian rhetoric going on. It even after that trial that basically tried to get, you know, creationism, what they view as false science, to not be taught. It was still incredibly difficult for teachers. I mean, I remember at my school, just, you know, when I was in high school in, you know, 2000, I think I graduated in 2007. I wasn't taught evolution. You know, they very much glossed over it out of fear of religious outrage from families in that context. So I think that, I don't know. I think the bias, I think, is often on the other side. Artemis, do you want to respond?
Yeah,
to,
I'm talking about in academia is where that exists. You know, there is a huge conservative Christian base, especially in America, that refuses to accept evolution. They're all young Earth creationists too. I don't know that they all are aware of any evidence in supporting that.
So there's actually a website you can go to called Darwin's Descent. Is it called darwinsdescent.org, where there's like over 1,000 PhD scientists who have signed a petition to stop teaching Darwinian evolution.
But by the way,
issues with it.
Well, then good job, because we aren't teaching Darwin. So I'm very confused. There's been a lot of claims thrown out and not a lot of backing, and I haven't been able to address many of them.
Did you say we're not teaching Darwin?
We
No,
definitely
Darwin.
are.
We speak on Darwin, but we don't teach Darwinian like evolution. We look into Mendel, and we look at modern scientists that have brought more forth. Like Darwin is considered the
Like
father of
who? Stephen Gould?
No, I was speaking on Mendel as one of the prime examples for genetics. I mean, we teach the modern synthesis, which is a combination of Darwin and Mendel. We're not just teaching Darwin.
Yeah, so
We also
we
look at
Yeah, but
Wallace.
that's
When-
all
when-
still called Darwinism.
When
though,
when we say Darwinian evolution, we mean all life goes back to one single cell organism. And Mendel agreed with the same exact thing.
Okay,
Mendel
but,
just
like,
helped try to prove it through
Okay, but-
genetics.
evolution and origins of life are
Yes.
two different topics.
No, they're not. They're all part of one topic. You can't have origin of life, and you can't not have origin of life and explain evolution. Like you
Well, no,
have
but
to
they're
be
not
able
the
to
same
connect
theory,
the
though.
dots.
But-
They're not the same
well,
theory.
I see what you're
Let me
saying.
just jump in for a second. I'm sorry,
Okay.
because I want to just clear this up. Yes, of course, for there to be evolution, there has to be some origin of life in any worldview, right? Whether it's the theistic or a
Correct.
different worldview. But the two are not explaining the same phenomenon. What could have led to the origin of life could be a very different mechanism than the mechanism of evolution that takes place after life came to be.
Yeah.
So these are very distinct. Again, and I urge anybody listening to this to look this up. Like now, you can have concerns about abiogenesis as a good explanation, but none of that is, I think, relevant to whether or not evolution as a theory holds up. And I also want to post this comment. I'm not sure what any of you think about this comment, but nobody thinks that all life went back to one organism except creationist strawmanning.
What's the comment? Oh,
Yeah,
I mean,
or nobody thinks
that's
that all
what
life.
abiogenesis is. So
that's not what abiogenesis is.
What's
Abiogenesis
abiogenesis?
is life coming from non-life. Go ahead, Artemis, if you have a definition.
Well,
Like
we've been
to hear
able to replicate this many different times, starting with the Miller-Urey experiment. I can list the other ones because people have issues with that one.
Nope.
But no,
There's
just no.
Well, hold on.
evidence.
Okay, so
Miller-Urey. Oh yeah,
Well,
finish.
Go ahead,
You can
Yeah.
finish, but I'll tell you right now, there's
Mhm.
been absolutely zero experiments that successfully created a cell. The Miller-Urey experiment has done the most, and that's only created some amino acids. You need lipids, you need carbohydrates, you need proteins, and you need
Nucleic acid or nucleotides? No. What is it? What you
lipids,
talking about, the fourth one?
carbohydrates, proteins, and I can't remember the last piece now. I think that is the amino acids. Yeah, amino
Yeah.
acids.
I just want to clear one thing real quick before you, Artemis, I'll get into that. There's a difference between saying it's coming from one organism and saying that life came from non-life. Like to me, that seems like the two are not synonymous.
Are you
well,
proposing that happened more than once? That life came from non-life more than once?
No, but I'm saying that the non-life that from which life emerged would not have been itself an organism. It would have been some other process. But yeah, Artemis, do you want to respond to what was said?
I was pulling up other studies that have been done, but the Miller-Urey experiment never says that it creates life. It showed that the building blocks for life could be made from inorganic material. That's all it states.
All it did was create some amino acids, and it
Mhm.
wasn't even in a prebiotic manner. So,
But it wasn't trying to create life, though. It was just trying to
it wasn't. It was showing
analyze.
that
so
we
why
building
are we
blocks.
using that as evidence of abiogenesis?
I'm not using it as evidence of abiogenesis, but it's a part of abiogenesis. And abiogenesis is, once again, a theory. There's many theories for the origins of life, which is why I said it's a different topic of discussion. We can talk about
Yeah.
evolution,
Yeah,
but the
maybe.
origins of life has many different theories enveloped with it. And if I knew we were going to go there, I would prepare more on that.
No. I think it's better. Maybe it's better. I think
We can not. We don't have to go on. But what it does do, because if you're going to say like you believe you take to panspermia, right? Aliens putting life on the earth, then that may differ your view on how evolution got started or where it started at, because they could have put a mouse and a reptile and something else on the planet as opposed to just the single cell. So it does have something to do with.
But how would that
what your
change
worldview
evolution?
would be.
Wait, hold on.
I don't think so.
Actually, no, hold on. How would that have changed how evolution progresses if they simply put a mouse? Would the
So
would
I
we
was
not
just
see evolution of the mouse?
I was just giving an example, but
I
I've
know, but
heard
I want to run with it. So
I've
like,
heard people that say that aliens put life on this planet, which could
okay,
fall into them putting one of every family of animal on this
okay,
planet, and then two human or two of each to breed, and then 2
Mhm.
human beings. I've heard people say this. Do I believe
okay,
it?
yeah.
No, but that would
Okay, so
not be the same route that the standard neo-Darwinian evolution would follow, which we all go back to the same
but
answer.
I'm not now using Darwinian. Like, I don't know why you keep bringing that up. I'm asking you specifically, would evolution not occur with those animals?
So a speciation would, microevolution would, absolutely. They would stay within their family. You would never see anything other than a Canidae family animal evolve over time from the original Canidae family animals. It would never go into anything. It would
Mhm.
never grow wings. It would never develop anything outside of what's capable in the Canidae family.
So you're speaking on the species that were before the Canidae family got separated. You're
So
saying those wouldn't have existed.
this is my problem with macroevolution. This is our problem, is we don't
Because I
think.
have examples. I have examples of this, but like I said, there's a lot of claims, and we're like bouncing around. I want to stick with like one point.
So okay, so give me an example of something that came into the Canidae family. What's
That
the
came into
preform?
well, I have the predecessor. We know what was the common ancestor of cats and dogs. We know
And
this
how do we know that?
through following the genetics and fossil records.
Okay, so genetics will not tell you that a Canidae family animal came from something that wasn't part of the Canidae family.
I'm not saying it came from something that wasn't the Canidae family. I'm saying that this was before the Canidae family existed.
So
That's the same thing.
That's the same thing.
No, it's
no.
it's
You're
actually
saying
not.
that
No, no,
something
no.
that was not X
No.
turned into X over
No,
time.
that's not what I'm stating at all.
So what
something
are you
that was
stating
not
then?
a canine turned into a Canidae turned into a Canidae.
Okay, but it like so. Are you like? Was there like a roll of the lottery for like which candidate it turned into then? Like, because we have many different forms of candidate. So like, which one are you referencing?
Maybe, okay, hold on a
Whatever the
second.
first one would be.
But what do you think the first one would be? Because this is again a lineage.
So it
Well,
doesn't
we're
matter.
not saying that we're not arguing that. We don't need to
Wait,
argue
okay,
what the first one was. We're saying the burden of proof is actually on you guys to actually show that this is possible.
Okay,
That
so
you're making.
a kind
let me
can,
say-
and you
let-
know what a kind is, so I can say the word kind, right? That one kind can emerge from another. You know, we're looking for that kind of evidence. That's why we
So it's a
distrust
meiosis, by the way. If
Oh,
anyone
okay,
wants
so
to
go
know, it's
ahead.
So
meiosis.
let me jump in for a second. Because maybe what might help is if we kind of explain the mechanics of what evolution actually is and how it's being understood in the scientific context, to maybe compare and contrast whether or not what you think is being said is actually what's being said. So, and I do want to post this comment. Artemis, would you want to? Do you think that there'd be a project worth?
Sorry, I was typing the information into the comments so that people could understand. What would you like me to do again?
No, I was going to say that maybe it would be beneficial to explain what the process of evolution is described in science, to see
Like the mechanisms.
the mechanisms. Yeah, to compare and contrast whether or not maybe Adam and Brendan's views on what the mechanics are maybe differ from what's being said. And maybe the disagreement is not with the actual theory of evolution, but with potentially a different understanding or a different a view of what that is. Like,
yeah, we can go through that. Like I said, we've hit a lot of different points, so we're just
was
all over the
was there
board.
anything specific that you wanted to address there?
No, I just like to stay on one path because, like, yes, I'm a biologist, but like I don't have all of biology in my head.
Yeah.
So I'm having to pull up references and sources also to back my information. So I'm kind of doing a lot at one time. I don't mind it. I just want to stick with one.
Yeah, maybe let's go into that. Let's go into the mechanics. I think that would help.
So yeah, let's, if you could, explain to us what came before the Canidae, what became the Canidae, and then how that happened.
Wait, okay, I thought I was explaining evolution.
Yeah,
This is part of evolution.
So you want me to explain it using the myicus?
So
Is what you want me to do?
What do you mean by myicus?
That's the common ancestor of the Canidae and the Felidae.
Okay, so this
Sure.
is neither a Canidae or a Felidae, correct?
No, it is not. No.
Okay, so I'd like
Well,
to
why
know.
don't we say whichever one you're most comfortable with? What is your biggest evidence for evolution? Let's go with that.
My
It
biggest
doesn't have to be
evidence
that specifically.
for evolution. I mean, there's not one thing. There's so many different like areas. It's like that's a kind of a like a huge question. Like,
Are you comfortable with this one we're talking about now, or would you prefer to talk about like a different family of animal or different stage of
well,
development?
I would say that like HERVs are like a great example of like evolution, at least with like being able to measure it between like us and other primates. But like I said, evolution is not just like a single concept. There's many different areas to it to help to understand the whole of it. That's why if I go over the mechanisms, there's 5 mechanisms involved with evolution. You've got genetic drift, gene flow, natural selection, mutation, and then you also have non-random mating. So each of these 5 different mechanisms all have different forms of selective pressures, and then they each have more webs that come off of them with each different experience.
And there's
So that's why,
evidence for each one of these
yes,
mechanisms.
yes.
Can
Okay.
you go into the retroactive viruses? I think that's a good piece
Yeah,
of
I can
evidence.
pull up the HERVs. So this is something that we've been able to measure. So it's human androgynous retroviruses. And we found, give me a second here. Like I said, got a lot of sources pulled up here. Okay, here we go. So this comes from, I got it right here. So this is from BMC Evolutionary Biology. This was published in 2018. So it shows, so HERVW group, evolutionary history. I can post it in the chat here for y'all if you want to read along. Just give me a second here. In the private chat here. There you go. The evolutionary history in non-human primates, characterization of ERVW, orthologs, and Carhina, and related ERV groups, and Plataherian. So this is looking at a virus. So androgynous retroviruses bind to our genome, and they stick with us. And so we know that about like early on, like in jawed animals specifically, an androgynous retrovirus infected a species and became bound with the genome, and so that stuck. And so we've been able to look at our genome when we found that out of our loci. So it's on our number 2011 on our, so we have 211 loci, and we can see that on our 211th loci that this androgynous retrovirus is still there. When we look at chimpanzees, they have it on their 205th loci. So that couldn't have just come out of nowhere. The mathematical improbability would be incalculable for them to both have the same exact retrovirus in the same area on the loci. We have more loci than they do, but it's found in the same area.
So I don't see how you can draw logically a conclusion because we have this similarity. Therefore, like we have the same amount of toes and fingers too. That
It's not the
doesn't.
same thing.
But it is a similarity.
No.
They are both similarities.
No,
And
this
so
is
to say
bound
that
to your
means we
genome.
came from them, that
Oh, I
doesn't
didn't say
seem
we
to-
came from them. We shared ancestor. That's why it's why it's not. That's
But
why we
that's
don't.
another conclusion that you're just like that doesn't show that we have the same ancestor. That just shows we have a similarity.
No, because it's not just a random similarity. It's the reason why that virus is there is because we've evolved from that ancestor to
That's a
have it there.
presupposition.
No,
Like,
it's an observation.
No, that's a
No, it
what
is a
follows-
presupposition because you
you
were not
have
there
to
to
prove
observe it.
that. You can't observe it, right? So
No,
the
but-
best we can do is use historical scientific methods, right? Or forensic scientific methods to try to see how we can show that this is evidence that we evolved from that.
Right, but here's what I'm trying to explain, though. It's not a presupposition. It's an observation based on the way that we understand viruses and how they work, and the what's the word I would use? The imprint left by these viruses. The only way in which we could have, again, it's a matter of understanding the mechanisms of the way in which these things work. And my concern is that, and it's also based on some of the questions you're asking, and this has been echoed in the comments a little bit, is that I don't think it's evolution that you guys disagree with. I think it's some interpretation of evolution that is not what's actually being expressed in the science.
That we do believe?
Yeah, that I think that you, to some degree, are strawmanning the theory by, and some of the questions that you've asked kind of, I think, point to a not understanding of the way the mechanisms actually are.
And I can explain better because I didn't explain that correctly.
Sure.
Speaking to an anthropologist on this really quickly. So to likelihood of this occurring with these retroviruses, the likelihood of sharing at least 12 of these loci would be more than the uncountable number of atoms in the universe, and we share 205 insertion sites of 211 loci.
And Jeremiah makes a good
Very
point here.
interesting.
We didn't have to watch a star form to understand how they form or how stellar nucleosynthesis operates. Indirect observations are used all the time.
Okay, but that's where philosophy starts to enter science. You know, we use this all the time. You know, like you have to make some kind of assumptions because you weren't exactly there. And you have to admit, the scientific method is anchored to observation. I mean, observation is the thing that made the scientific revolution start. You know, it's the idea that repeated observations will be consistent, and that there's like consistent laws in nature. But so once we leave observation, you know, you go into forensic or historical sciences, which, because you weren't there, you have to provide you have to have some level of assumptions. And that's what we're saying, is you haven't actually seen this happen. You know, like the common ancestor, I don't know if you believe it's Australopithecus afarensis, you know, that we came from that, both apes and humans. We haven't seen that. And so you're saying, well, we have these similar creatures. And so that's the evidence that we came from one. But couldn't it just be that we have, instead of a common ancestor, they just have a common designer, right?
But wait,
That's
hold on, quick question.
Interesting quip, but that's just to say, you see, and we have an easy rescuing device with this. You can easily see this, not to use the bad connotation of the word rescuing device, but God could have easily just made them similar, right? And because we don't have direct evidence that one turned into the other, in fact, we have evidence to the contrary, that it's actually impossible to add substantive genetic information to the gene code over time, right? Mutations do for a little bit, but it's not something that will populate the earth with a whole variety of species, right? Like that's quite a claim. And so that's what we're debating, right? And so we just, because we have that working against the idea that from Australopithecus, that we have these two other organisms come out from that, humans and apes. That's why we don't think similarity is quite enough.
But so much more than that is being provided. You're making the claim that these things are not being observed; they're just being assumed or just deduced. What's being explained to you is that that's not the case. And if you cared to that degree about observation, then this unfalsifiable position that God created all of this, when you can't observe that. The observation
God is supernatural. You can't use natural. It's not analogous. Like God is a supernatural being, so evolution is not a supernatural process. It's not supposed to be.
Well, no. But this is the thing, though. This is exactly the thing. If what I'm suggesting is that actually these things have been observed, for example, in fruit flies, but also the mechanisms.
Fruit fly, but you just said right there, the fruit fly, all the speciation experiments and everything that they've tried to do, it's never not been a fly. It's always remained a fly.
But nobody's claiming
that's not how it works.
This is what
it would have to become something else to substantiate it.
This is what I mean about not understanding the mechanism.
Why?
That's not what evolution says.
Hold on, Cease. Why? Why does it have to become something else for it to be evolution?
Because we've now observed...
to be the evolution that we're rejecting, it would have to become something else.
That's my point, is that what you're rejecting is not the theory of evolution as it's explained in the science.
Well, Cease, we had to get from amoeba to us somehow, right? It's a big change. Yeah. Many different examples of certain types of organisms becoming wholly different types of organisms.
Yeah, that's what happens.
If we don't see that in the fruit fly, or we don't see that in the bacteria, even though it can reproduce so fast, then, I mean, that kind of works against evolution.
No, at all. Arthur, do you want to address this? Because you're the biologist, but
Like I said, this is just bouncing all over the place. I'm just like, I'm pulling up different information, but you're not answering any of my questions. Like, I'm really bringing up a source that overspeciation within us with our Y chromosome is showing depletion of it. That doesn't mean that when it's gone that we won't be able to have reproduction. It just means that we're evolving.
I don't see the relevance.
It's exceptionally relevant because we have evolution within humans today.
But you're saying we're going to eventually not be humans when
No,
that's
the misconception. But you don't understand. Like, that is not what evolution is stating. That one species becomes another. That's not what evolution is stating.
Oh, actually, it does.
That is what
No, it doesn't.
No, it doesn't.
Yes,
It
it does.
doesn't.
It's called
Okay, well then
speciation.
we won't call it evolution. Whatever that mechanism is that initially Darwin even claimed this, goes right against Genesis, a literal interpretation of Genesis, with God specially creating organisms, not from them developing from each other.
Okay.
Right? Whatever that is, we disagree with that.
Perfect. Okay. So let me address two issues here. Because what you just said, I think, points to what I was talking about earlier in the beginning of the episode, which is the claim that you're making is that you reject evolution based on the science. But that's not what's going on. Because I don't think that the science is being understood correctly in the way that you guys are expressing what you think evolution is. What I think the motivator seems to me, for what you just said, is you have this story about Genesis, and you want that story to be true. You want what you believe to fit that narrative.
No,
that's what it sounds like.
No,
No, that's just how I named it, because I felt like that was something that was an umbrella I could fit it all under. And yeah, I mean, we are looking for things that do match up with scripture. We are, right? However, if you could provide some evidence that really does go against that, we would love to hear it. And that's,
right, so
that's what we're asking you today.
My concern is this, right? Like, so you're saying that these are things are not observed, but we bring you examples of what we think.
You've given us no examples of what
I would disagree with that. But let me
give me an example of something of one family of animal going into another.
Well, so hold on. So okay, this is not what's being said. This is the problem. Is that
it has to have happened for the evolutionary timeline?
No. But this is the problem. Let me address this. That I think that the timeline is not being understood. The mechanism is not being. Nobody's claiming that for evolution to be true, you will go from one species producing another species in a generation. That's nobody's saying.
Species is not the problem because we've observed speciation. For example, like
have you heard of polyploid? Have you heard of polyploid?
Yes.
You heard of polyploid?
Yes.
So are you familiar with the white-throated sparrow?
Yes.
You are. Okay.
Yes,
so
I've had this argument before. Now, let me ask you this before we even go down that. Pakicetus. You know what that is?
I am not familiar, but I can certainly re-educate myself.
So Pakicetus is supposedly the ancestor to a whale. Okay. So if you guys can, look up a Pakicetus. Right?
Yeah.
So see where I would have some issues just from looking at it on the front hand, how this became a whale.
Could I ask you a question? If I showed you a chihuahua and I said this came from a wolf, would you have a hard time believing that came from a wolf?
Well, it's kind of hard for me to say that because I have the curse of knowledge. I know that it did.
But if you didn't have the knowledge,
would
it be really difficult?
I see that.
I see what you're saying.
I think Pakicetus and whale are a lot farther than
they are farther.
Chihuahua
They are,
to wolf.
but they are far apart. But we have the entire fossil record from them to the whale that we're talking about.
Okay, so the fossil record. Let's talk about the fossil record. Okay. So because of fossils, which really are just proof of dead animals or whatever we're observing, where does the line where how do we draw the distinction? Oh, well, these fossils look kind of similar. That means they evolved over long periods of time into one another.
So you're asking about transitional fossils?
Sure. Let's talk about that.
These are transitions between them. Like what you consider to be a transition is still a species. You're not going to have a weird non-species between the two of them. So this was also the split off between hippopotamuses and then going into male whales. So that species it's listed is the one that was the predecessor before hippopotamus and whales went their separate ways.
So
which you can see that in the picture. If you look at it, I could definitely say, that does look a little bit like a hippopotamus.
I think part of the issue here is
Pakicetus looks like a rodent, a large rodent. Yeah. It doesn't look anything like a hippopotamus, nor does it look anything like a whale. And so
have you looked at a hippopotamus?
Yes.
Okay, yes. But it does have similar features. I'm not saying it's an exact match, but like to sit there and be disingenuous, like even looking at its feet.
Wait, I have a question real quick. Because we were talking about observation and the claim that, well, it can't be science because science can't observe this on such a large scale, which I think is
observational science.
Do you think that because we never met our great grandparents, that we don't have a scientific understanding of reproduction?
That's just a false equivocation fallacy.
Like, yeah, that one's interesting because we know about our ancestors because it's written down, just like we know about Noah's flood because it's written down.
Well,
in multiple different cultures all over the world.
True.
You see what I mean? But you see what I'm saying? Like that's we know specifically about our ancestors, their names and what they used to do because it was written down. So that philosophy works well and carries.
But that itself doesn't explain. That itself wouldn't explain the mechanism. It might tell us itself wouldn't.
But it says it happened.
So also, you said would we not know how to reproduce? I mean, so sexual attraction is built into us as
no, that's not what I was saying.
Beings.
I'm sorry. That's not what I meant. It's not that we wouldn't know how to reproduce. What I'm saying is that the biological mechanisms for reproduction, the understanding of the process, not obviously that would be an instinctual thing to know how to. That's not what I'm talking about. I'm saying that there are certain phenomena that take place over large periods of time, and while we may be incapable of observing that from the outside, it doesn't mean that we can't understand the mechanisms and figure out that if this is true on a small scale, it's going to lead to these conclusions on a large scale. I think you have this idea of evolution that to me sounds like a Pokemon type of scenario.
I mean, that's what most people say, but ultimately what you're doing is you're saying because we see this on a small scale, therefore we know this happened on a large scale, but we didn't observe it. We're just making an assertion.
No, I think we're making the only reasonable conclusion based on what we are observing on a small scale. The issue here is on a large
the only
time,
reasonable conclusion.
Here's why, and let me try to phrase it this way. If these changes on a small scale are true, and we can observe these small changes, the question is, what does the world look like on the large scale? What are these over time groupings of changes lead to?
Okay,
and I think it leads to what we observe, that things now being so different than what they were.
I see where you're saying the logic would follow. We see that. The problem is with microevolution or speciation, better term. It's an entirely different process than what is needed for macroevolution to happen. It's down selecting in a gene code. It's not building up on a gene code, right? And so over time, you'll hit a wall, just like you do with Pomeranian, right? Or like poodles, for example, right? There are these barriers to survival that start to emerge. Like poodles, their hair never stops growing, right? So no poodle family really would go and survive well in the wild because they'd get stuck in all the bushes with their extremely long hair, yeah. So eventually really that's what happens. You hit barriers, and that's what we're observing. Like there's an example, boom, right there. You got so far in the gene code from wolf, which was the survivable ideal, maybe we could say. Maybe there's some other survivable ideals on the way to poodle, but then you get, or Pomeranian, but then you get all the way this far away from where it was originally. and it starts to have issues surviving, right? And so you hit a wall. Now, that's what we're saying what would happen if you propagated macroevolution ad infinitum. You kept going, you would hit that wall. With macro, right? Not speciation, but actually the evolution required to go from molecules to man. That's an entirely different process. You'd have to grow the gene code. You'd have to add a bunch of information. And that's what we're saying there's no evidence for.
No, so again, I think that two things are being ignored. One is that what you just described is because of, like I posted, human intervention. We bred dogs to be that way. That doesn't apply to evolutionary
is
theory.
that not just rapid natural selection?
No, that's domestic and selective breeding.
Right.
But
domestic
listen,
and selective breeding is nothing more than a sped up natural selection.
When you
with
say
a mind to guide it.
When you say that
so
you
even through design in there, and you still hit these barriers.
When you say that you believe in speciation but not macroevolution, I think what we're trying to express to you is that microevolution is what's true when speciation among a number of other things that have been observed are true. Artemis, was there anything that you wanted to add?
I mean, there's a lot I'd like
okay,
to add.
Go ahead. Well, you haven't been talking for a while, so.
Well, I mean, I don't want to interrupt.
No. I want to give you a chance to get across some of.
So, like I said before, like there's like we can have like new species. Like a new species does not mean a new kind. Like I really wanted to hammer home that
we agree.
Doesn't. Okay.
Mm-hmm.
So for instance, like allopathic speciation will create new species, and we can observe this because it can happen instantaneously. Not instantaneously in the sense of a new species, that's polyploid, we could go into with plants. But in reference to allopathic speciation, for instance, like its geographical barrier separates one species into two. And with enough time, they can't reproduce any longer through selective pressures. And we also saw this with finches, which was also talked a little bit about with Darwin, if we want to reference Darwin, since you guys seem to like him a lot. We saw this we see this with the large beak finches had higher ability to crack nuts, but the smaller beaked finches had better accessibility to food. They each had their own little niches that they fit and worked in, but they were separated. They didn't eat the same types of food because of their beaks, which is a form of speciation. Speciation is not just the creation of a new species. There's different aspects that come into it. I think that's what I'm trying to hammer home is there's this concept that and that's all I've ever talked about macroevolution is new species evolving. That's simply not the case. It could be different species evolving different mechanisms.
Okay, so what you're saying is that one group will be separated from another group over time. There'll be a different environment when they're separated into, and that will produce different phenotypes to emerge.
Not just phenotypes. It'll come down to they can't even reproduce.
Yeah. Okay. So I'm not sure why that would be evidence for an addition to information in the gene code. We actually know examples where the gene code was not added to. There was just a separation over a long period of time, and that caused.
I'm confused. Can you explain the adding to the? Can you explain to me what you mean by adding to the gene code? I'm a little lost on what you mean by that.
More chromosomes.
So would you say that our chromosome like that we would add? So for instance,
well, actually, that's not true. Don't go down that path. I made a mistake. There are certain animals with much less complexity than humans who have more chromosomes.
But I'm still confused. Like, what do you like? You keep saying addition of chromosomes are taking away from it, and that's not exactly what's happening. So I'm a little lost.
I mean, it's information. It is the addition of information.
But for instance, we went from 48 to 46 chromosomes. We just had a base pair combined sometime in our evolution. Because
who had the 48?
I could tell you had the 48. I believe it.
Is that the Australopith?
The genus retrovirus added to the gene code. Yeah, I'm not sure that this concept of adding and subtracting is itself what I think it's being said in the sciences. This is what I keep kind of going back to, is that I think
Artemis agreed to that in the beginning.
No,
Sorry to
What?
interrupt
no,
you.
no, no. They're asking you what you mean by that because it doesn't sound like, again, what's actually being expressed
So
as far as a mechanism.
let's give a specific example, and let me know, Artemis, when you come up with that.
Yeah,
Which,
I have it. I have it right here.
okay, go ahead.
So
Go with that first.
great apes had 48 chromosomes. Modern humans, Neanderthals, and the Denisovans had 46.
And so you had said that we used to have 48, which is presupposing that we were an Australopithecus.
There's many other. I would say more like a closer one would be like Homo erectus or things like that. Like I'm only listing 3 modern hominids.
Did you see how you just said the Denisovans and the Neanderthals had the same amount of chromosomes that we do?
Yes, that's
Okay. And that also Neanderthals used to be considered, what's the word I'm looking for? A hominid
we are.
before, I know, but before Homo sapiens, like entirely separate on the way from Australopithecus?
I mean, I'm a little confused. Do you mean like as a linear line? Because it's not a linear line. I can bring up a diagram to show you that human evolution is not a linear line. That they existed
I'm not
before
sure
us,
what you
but
mean by linear, but just a evolutionary step on the way to Homo sapiens.
that's
Yeah, but-
not how I was taught it at all.
That they
Yeah.
emerged first. That they
No,
emerged.
They did
earlier.
emerge first,
Th-
and then
but-
they met us.
Okay,
What
so
I'm saying
what I
is we
mean.
should change the scientific name from Homo neanderthalensis to Homo sapiens neanderthalensis
Why?
because they're actually just humans.
They're not. No, they're not.
No, but they are. Number one, we just see where you just said they have
No.
the same chromosome number. Now, that's not conclusive evidence right there, but that's interesting that you just mentioned that. But then we find other evidence, like they made makeup, traveled great distance across the seas,
Wait, I never
hunted
said any of that.
animals. You
I
know,
never
they're
said any
clearly
of that.
distinguished. No. Wait,
we have evidence that
we have
Neanderthal
evidence
tribes
that
did
they
that.
actually made makeup, had elaborate burial rituals.
They
Oh
had
yeah,
tools.
Neanderthals
That wouldn't
were
make them
most
even if
definitely
that was
human.
What
true,
does
it wouldn't
this
make them
have
human.
to do with what I'm speaking on?
So,
Well,
just real
it
quick,
puts them in the level of humans. I mean, they
they're
were
They are
not.
Homo
capable of
sapiens.
doing everything humans can do.
I've seen
But-
videos. I've seen videos of chimpanzees putting glasses on their face. Doesn't mean
Okay.
that makes them human. Like
That's
these
not
are.
making
Okay.
tools and making boats and sailing.
I've seen
across
crows.
the-
Crows make tools. I've seen
Have you seen
chimps make
crows
tools.
or chimps create boats, sail out to another
No.
island, and establish a
But
colony?
that's
no,
besides
That would
the
be
point.
impressive, man. I'd like to see that.
Cease,
No,
hold
no,
on.
don't
I'd like to
make
ask this question. Why would chimpanzees need that?
Right. Nobody's claiming that.
To get away from some predators, maybe.
They can get away
Well-
from predators just fine. Why would they need to build a boat?
I don't know.
that's
Why do
irrelevant.
Neanderthals need to build a boat? It turns out they did.
You're deflecting.
But-
Why would a chimpanzee? Hold on, Cease. This is part of the area that I work in. Why do you assume that chimpanzees or other
Alright.
animals have to evolve the same way we did?
We,
All right.
we don't think
Volcanic eruption.
A volcanic eruption?
Sure. I could come up with any hypothetical.
Okay,
they did.
but
Brendan, we don't think that chimpanzees have ever done that. So I don't know why you're asking this.
I'm not even saying in conjunction with humans. I'm saying comparison. Like the chimpanzees are still evolving. So bringing the instance of like you haven't seen a chimpanzee build a boat and sail and colonize. My question is, why would they need to in the first place?
Well, if, for example, they were running from a predator or something like that, they could do that if they were capable, but they're incapable. So it doesn't matter. They can't
Well,
do that.
who are you to determine if they're capable or not? They don't need it at this time.
So you're saying
Now,
if the
hold
need
on.
arises, they'll figure it out.
That's how evolution works, by selective pressures.
So have you observed that?
Yes, we know that orangutans spearfish.
So that's not on the level of building a boat.
It doesn't have to be. But
It
that's
doesn't have to be. They don't
nobody's
need a
claiming.
boat. Why would they need
No.
a boat?
An orangutan, one place may have at one point speared
No,
a fish.
no. This
but
is
it is not
documented.
normative of
Yes,
the
it is.
orangutan
Yes, it
population.
is. Absolutely. it
Normative?
is.
Whoa, I'd
Yes.
love to see that evidence or some kind of I don't
could
know.
pull
What would
that
you
up.
need,
I
like
could
some
also
kind of
pull up
paper?
kinship ties and macaques. I mean, where do you want me to stop?
Yeah, interesting.
Okay.
Very
Yeah.
interesting.
I've-
So let's get back to we kind of going down the rabbit trail here, but I wanted to get to something that we never really addressed. So specifically with Pakicetus, I'm going to take it back to Pakicetus. This was supposedly the ancestor to whales and hippopotamuses, right? So we look at a Pakicetus, 6 feet long animal. Looks kind of like a thylacoleo, lack of a better term. If you're familiar with thylacoleo, it's a old what do you call it? With the 2 teeth. I can't remember the term now. Not rodent.
Marsupial.
Marsupial. That's the term, right? So this would have had to have the claim is that over millions and millions of years, this Pakicetus became a whale and a hippopotamus, right? There's no way.
Didn't. It's not a Pakicetus did it. It's several other species between
the transitional species in between, but that is the ancestor.
was one ancestor.
But what I'm saying is there is no possible way to observe that.
What do you mean by observable? Because
to look at it with your eyes, to observe it in a lab.
That's not what observable means in science at all. We
to
use
observe
measurement.
It in a lab?
No, this is what I was trying to get to. Observation can be used with like measurement and inconsistent findings.
That's cool too.
Okay.
But that's another area of science that you're not understanding, is that we don't have to observe it with our eyes. We can measure it.
I mean,
Measure
I think
what?
you're talking about like yeah, we don't directly observe atoms. We use scanning electron microscopes. Yeah, we don't observe them with our eyes. We measure them other means. Yeah, but that's in real time. That's what we're talking about. Real time.
I'm talking about like literally in front of us, whether it's through a measurement or anything. We've never seen this happen.
But it doesn't make that question doesn't make any sense.
We don't need to see it happen to measure that it did.
Right.
How can you measure that it did?
Because we have evidence left behind.
What evidence?
We have fossil records, yes.
That's not evidence of evolution. That's evidence of animals that existed at one time that look kind of similar or have somewhat similar traits.
That's not how we link them.
Well, that's the problem.
But it's far more than just the fossil records. Like again,
what else?
The evidence. So, like it was just like we've been trying to explain, what we find in genetics, the
you can't test the genetics of these. That's not possible unless you have soft tissue where you can look at their DNA.
No, I'm talking about understanding the mechanisms of genetics, understanding the mechanisms of the imprints that, like what we were talking about earlier, the viruses leave on genetics. It's like you're saying that we can't observe it, but every time, and this is why I was talking about like motivated reasoning, because every time we give you an example,
you're not giving me an example. You're presupposing it is an example.
I don't think
how can you test the DNA of fossils that are supposedly billions of years old, or millions?
No, I wasn't talking about fossils here. I'm saying the fossil record is one piece of evidence, but I'm saying
that's the only bit of evidence that we have for this specific. So what's the other evidence?
So again, let me
for Pakicetus to whale.
Let me. Well, Artemis might have the answer to that. I'm not sure with a specific example. What I think, what I'm trying to express here, is that you have a caricature of evolution, and if that's what you're dismissing, this view, the way of the view of evolution you've expressed, I don't believe in that version of evolution, and neither does anybody in the sciences. You have the story you're telling, what you're expecting to see, is like I was saying earlier, like a Pokemon type of evolution.
Nope.
On a linear line that of this immediate change that would happen from species to species.
Oh, I understand that it's impossible for us to observe it. So that's where my problem is.
But what you're...
Why don't we not just put the burden on you guys to actually say what evidence is for evolution? I'd like to propose 2 problems that we believe exist with evolution. So it's actually evidence against evolution ever happening. So, I mean, we already talked about the lack of information or evidence that information could be added to the G code. I've brought that up before. We talked about that for a while. But what do you think of things like living fossils, where you have organisms, animals like the, what is it called? The horseshoe crab that exists in the lowest strata archaeologically. And so it's very, very old, but for some reason still exists today unchanged. Wouldn't it seem that evolution was not acting in this organism? Because it went through millions of years with no changes.
Horseshoe
And
crabs.
coelacanths.
Yeah, that's another one too.
I think
Those are called living fossils.
I gotcha.
I'm trying to find this comment I want to show.
And so the issue is it would seem kind of arbitrary that natural selection is going to affect everything else, genetic mutation, everything else except these two among other living fossils as well.
This was a comment I wanted to show. You don't see a black hole, but you observe the result the gravity has on things around it. Again, this requirement, which I think is completely unreasonable, that for evolution to be reasonable, we would have to observe something that is inherently on a large scale in a small scale doesn't make any sense. It just doesn't.
No,
make
I
any
see
sense.
what you're saying with the black hole example. We see what you're saying. Oh, it's a small example of something. Just extrapolate it out. We can easily see that. If you see a tomato plant grow a little bit out of the ground and then come back a month and a half later and it's really tall and has tomatoes growing on it, yeah, you can reasonably assume that little plant turned into the big plant and produced a bunch of fruit. You can do that. The problem is the initial steps that we're talking about here, speciation, is a different process entirely from what macroevolution would require. And so we're saying if you grew that little plant up, it would look nothing like macroevolution. It would look like something else. That's what we're saying. So this is totally different. You guys are kind of giving us a small version of a straw man argument. It's actually a big version.
Because you're saying that
we're
over
rejecting.
and over.
Go ahead.
No, go ahead, Brendan. Sorry.
What we're saying is that what you're calling macroevolution and what that would look like if macroevolution was true is not what macroevolution is. Macroevolution is what happens on the long time scale.
It's Pachycetus to whale.
If speciation is true.
Pachycetus to whale is an example of macroevolution.
So I can answer the horseshoe crab thing if you would.
Before you do that, Artemis, let me mention something really quickly to cease. What you just said right there is an unfalsifiable claim.
No, not at all.
You see that? You just said macroevolution is defined as microevolution propagated over a long period of time.
How is that unfalsifiable? That's
because
literally deduced.
We agree. No. What we're saying is we're changing definitions here. We're saying that's not what macroevolution is. And then you're saying that it is. And then you're saying that's the evidence for it. Well, hold up. We haven't proven that that's what macroevolution is yet. There's no consensus.
Well, no, that is how it's
so
defined.
You're assuming the consequence.
No, not at all. Not even remotely. What I'm suggesting is that your definition or understanding of what evolution is as a theory and what it's stating is incorrect. You're making this distinction between speciation and a straw man of macroevolution that
I just gave
doesn't make any sense.
That's
so let's just say speciation, if you allow it to propagate ad infinitum, will never result in Pachycetus turning into a whale. Let's just say that.
Okay, so yeah, I mean, obviously I don't agree with that, but I want to hear
right.
Artemis wanted
Why?
To say.
You see that's what we're getting at.
That's our problem.
So real quick, because Artemis said they wanted.
Yes.
I'll answer.
Go ahead, Artemis.
Yes.
And I do have to end this in a few minutes.
So a few things about
you
horseshoe
do?
crabs. So first of all, there
almost
weren't selective pressures on them for most of their existence and still their existence, but we do have extinct species that came off of horseshoe crabs to show that there was an attempt for more variety of them, but they didn't make it. So I can give you those species if you would like.
How did we know those pressures were an issue before we could test them?
Because we can see based upon where they live.
So I find it strange. I'm sorry, you're saying that they did not experience these pressures that would normally cause an organism to change?
They did have small, minute changes in evolution, but not significant. Because they were in a good niche, didn't have selective pressures.
Okay.
They live at the bottom of the ocean, and I'm pretty sure very deep at levels of it. And if you actually look, there's a lot of sea creatures that haven't had a lot of change because there's very little change occurring at those levels.
So they live right on the beach because we see them all the time. But they had to live through that, I forget what it's called, but the Yucatan meteor that took out the dinosaurs 65 million years ago. They had to live through that.
Well, they didn't take
That
out
is
every
a
dinosaur.
huge environment change.
It's a misunderstanding on the meteor.
But it took out most, right? We have crocodiles.
Not necessarily. It changed the environment.
You see what I'm saying? It would have changed the environment.
And
Did
there
it
are
change the oceans
Yeah.
in that area.
in
Yes.
that area?
Remember,
Right, in that
horseshoe crabs live
area.
on beaches, though.
Yeah, like if you look up the Chesapeake Bay, there are tons of horseshoe crabs. I've stepped on so many I
Yes,
can't even count.
so have
They're
I.
they're everywhere. They're not just at the
Yeah, so
bottom.
I'm looking at different areas that they live in. There are 4 species of horseshoe crabs still around. Only one species, the one you're referring to, is the living fossil. Lemurius polynymphius is found in North America along the Atlantic and Gulf Coast from Maine to Mexico. The other 3 species are found in Southeast Asia.
Can you? Yeah,
Go
sorry.
ahead.
Said Gulf Coast.
No, sorry. Continue. Or
I was just mentioning.
what I wasn't understanding is this idea that if microevolution was true, that it doesn't explain the existence of the whale. Artemis, do you have any idea why that's being said? Like, I don't know what that
So
means.
let me clarify, because I don't think we're just kind of talking past each other on this issue. So in order for Pakicetus to get to whale, macroevolution must happen. And according to the current theory, is it took a long time, millions and millions and millions of years to go through several transitional species to get to whale. But ultimately, the whale's ancestor is a Pakicetus, right? A totally different type of animal. Totally different type of animal. Land animal, not water animal. Goes into a water animal. So that right there, that process, you can't say that microevolution happened a bunch of times and then it got to a whale, or speciation happened a bunch of times and it got to a whale. Macroevolution is not microevolution a bunch of times over and over again, and then eventually you'll get several different things from one ancestor. No, that's not provable. That's not observed. Microevolution, it'll always be within that species or a new subspecies, like Darwin and the finches. A finch will change its beak size maybe to adjust to the island to be able to crack the nut open. A beetle will lose its function to fly with its wings, so it doesn't fly off in the wind on the Galapagos Islands. But ultimately, it will always be a beetle. It will never become something else, either millions of years or not. You see what I'm saying? We can't say that.
So you made a claim. Do you have evidence to back it?
We've never observed otherwise.
That's not evidence. Do you have a source? Do you have something instead of just saying no, it doesn't happen?
All of the evidence we have shows that has not happened.
Which is like, what evidence is that?
Like the Galapagos Island beetles that I was just speaking about. Darwin observed them, and all they did was lose their wing function. They were still beetles, right?
That plus the horseshoe crab thing is evidence, plus the coelacanth fish, and then the fact that we don't have evidence of adding this information to the gene code that we've mentioned a bunch of times, that would be evidence that this doesn't happen. And then I did want to mention one more, and I know you want to end this soon, Cease.
Hold on a second. What about the Pachyceta that you mentioned? Pachycetidae is the family. Did you know that there were 3 creatures in that family?
Okay.
I did not.
One of them is an early whale.
Again, that's an assumption.
No, it's not. It was lived in freshwater environment. We know this.
Okay, so it had flippers.
Yes.
And it had a blowhole on the top of its head.
Well,
and it did not hunt little land creatures.
Wait, hold on. Not modern day whale.
Oh, okay. What kind of whale?
It was an early whale, fossils which have been found in the red beds in Punjab, Pakistan. Nellicetius lived in the freshwater environment with amphibious and carnivores.
So again, we're using fossils, dead bones, to show that something evolved.
Hold up. Fossils are not like bones. Fossils come from like
They're
mineral
fossilized
deposits.
bones. Yes, I understand how the fossilization process works.
Okay.
Yeah.
Could you provide us with the definition of evolution?
I mean, there's like multiple definitions. That's why I try to say I don't disagree with evolution, because we've observed microevolution. I disagree specifically with neo-Darwinian evolution, that the fact that we all evolved from a single ancestor. All of life came from one ancestor.
So, I'm trying to think of how to navigate this.
Amoeba, single cell, whatever you want to call it.
Let us do this, because because I do feel like we're kind of hit a brick wall here,
Mhm.
and I think the issue remains is that I think we have two different understandings of what the mechanism of evolution is. That's what I'm gathering from this conversation. Is that the things that you were saying you would expect if evolution was true don't really make sense to me, because I don't think that the picture you're constructing is very close to the scientific picture. And I think that when you're asking for observations, when we everything that I think would absolutely count as an observation for the theory, you're calling an assumption. And it's like it's this strange hyper skepticism that you don't apply to every other belief system that you have. You don't apply, and again, to just say, well, this is natural claim, this is a supernatural claim, that seems like doesn't make sense to me. It seems like a inconsistency in your approach to
Science
truth.
can't. Science is the study of the natural world.
Yes, of course, I agree with that. But,
Well,
but
so
why
why?
don't
why-
you test that?
But
Why
why?
don't you test us on our defense for, say, Noah's flood?
No, I think we did earlier. I don't find your explanation to be convincing, because I don't
I didn't
think
go through
that.
lots of evidences or arguments.
And
for Noah's
maybe we can have that be the next topic when you guys come back, if you guys want to come back.
Understood.
Is,
Sure. I think it
talk
would
about
be
the flood.
it would be productive to go over specific, like not just have a debate on evolution, because there are many things that we agree with and then many things we disagree with within evolution. That's why it would be better to say, like, let's have a discussion on how old the earth is, right? That's vitally important for Darwinian evolution to work, because if the earth is not millions of years old, let's say it's 10,000 years old or 7,000 years old, then there's no way you can even have neo-Darwinian evolution. Or even if it's 1 million years old, you can't have it.
Sure.
Right. So, or we could have a specific discussion where we only talk about the macroevolution process, like the evidence for that, why fossils would or wouldn't count.
Sure.
Like something a little more specific.
Specific.
And I think this would really help with Artemis specifically, because she wants to stay on one topic, and it's very easy with such a broad topic to go,
Yeah.
all over
Yeah,
the place.
I think that's a good idea. Here's what I'd like. How about we kind of go around and you all give sort of your closing statements, your impressions of, or what you would like the audience to come away with from your viewpoints and what you think about the conversation. And
Okay.
And you can go first, Brendan.
Okay. Number one, I just want to say thank you so much for having us on. It's great talking with you guys. These kind of conversations are important, and they're intellectually rigorous. And so I appreciate the opportunity. Talking about worldviews is a passion of ours. So thank you for that. But we just believe that macro evolution, being defined as something as the vehicle through which all of the species, all the genetic variation that we have on the earth today, all animals, emerged ultimately from some single-celled organism. That's what macroevolution is. It's the change in large taxonomic groups like family. Okay, while microevolution would be change in small groups. What we're submitting to you today is that the microevolution, the change in small taxonomic groups, is entirely achievable with just subtraction from the gene code, not addition. In fact, we've only ever seen subtraction from the gene code. And so it's separate from macroevolution and doesn't provide any evidence for that. And so because of that, scientifically, we are skeptical of macroevolution. We don't think there's enough evidence to support that. So that's the genetic argument. But then also from archaeology, just because there's some similarity among fossils that have been found, it's actually not enough to say that one became another. That right similarity doesn't necessarily mean direct ancestry or even common ancestry or anything like that. And we didn't really get into archaeology, but maybe in the future we can get even deeper into that, like the strata and how they're organized within the strata. But But that's really scientifically the why we have this viewpoint. But then we also do place the Bible as being an authority. We believe the Bible makes accurate historical claims. Genesis is a history book because it's written in historical narrative. And so we believe there's a lot of good historical insights that come from it. And so we are allowing that to comment on our understanding here. And as far as it seems to us, science and Genesis shake hands. That's what it seems like to us. And so that's why we believe what we believe.
Okay. Adam?
Yeah, again, Cease, thanks for bringing us on the channel again. You know, it's fun to get into it and things that you're passionate about. So I appreciate you guys being good sports. And I hope we can come back and continue this conversation. We'll try to, like I said, do it specific topic by specific topic so we can really get into the weeds and
Sure.
have a more productive discussion. But I do, you know, I agree with what Brendan said. I think ultimately, to me, it's about finding the truth. I'm not necessarily saying, well, I want to find what matches the Bible, because if the Bible is wrong, why would I want to follow it? That would be silly. I don't want to follow the Bible if the Bible's wrong. I want to find the truth. So far, the truth has been in line with the Bible. You may disagree with that, but that's what I've found. And it's not because the Bible says so. I think it's silly when people say that's what they believe the origins are. You need to look into philosophy and science before you go saying that, because then the moment somebody questions you and gives you a question you can't answer, you're going to lose your faith. So that's silly to me. I think you should have an intellectual understanding of what you believe and be willing to argue those. And so my beliefs are based off of not only biblical history, but the scientific history that I found. And I think when we get into more specific discussions on each of these topics and we can lay out studies and lay out our agreements and disagreements, I think that our position will be a lot more clear. And you'll see that there is some very shaky ground that our current understanding is on. I encourage everybody to go to darwinsdescent.org and see the over 1,000 PhD scientists who disagree with Darwinian evolution. And then, of course, check out our YouTube channel, Truth Over Tea, at Truth Over Tea, where we do Christian apologetics and podcasts and all sorts of stuff. And we bug guys like Cease. So thank you.
Artemis?
Okay. So thank you so much for having me on the show. It's been a pleasure. Definitely have a lot of tabs open. I think what I would like people to take away from this is that evolution, micro, macro, whichever aspect you want to look at, is not a simple concept. It's never been a simple concept. That's why we have different branches in science that go specifically into it. I am a general biologist, but there are evolutionary biologists, there's evolutionary cognitionists, there's ethology, there's many different other forms that go into the complexities of it. So to be able to hash all this out in one segment is very difficult. So I do recommend people to understand that, like, science itself is a tool. It's not the arbiter of everything is or isn't to be. And I think that there's a lot of misunderstandings that unfortunately come through just our public education system that people don't learn until later on in life, and that's completely fine. I think that perhaps all of us should come to topics more with an open mind and understanding about each of our things. We can walk through it instead of just throwing things off. But that's just my own perspective. And I would like to point out that there's over 524,000 peer-reviewed research papers that do back evolution. And I think that if your first step is to debunk any aspect of evolution, whether it be macro, micro, or evolution altogether, would be finding the falsehoods in those papers, because that would be a good start.
Is that it?
Yes, that's it. Thank you.
Okay, so I guess I'll say my closing statement. I'm trying to think how to express this on the fly here, because I think that I appreciate you guys coming on and the conversations that we've had. You've both been good sports as well, like you said. It's man, I'm going to say this, and I don't mean it to be in a disrespectful way. This is just my feelings. You tell me that you're motivated by wanting to know the truth, and that you wouldn't believe in the Bible if it wasn't true, or if you had good reasons to not believe in it. And in the same sentence, you say something that I think is blatantly false, and maybe we can get to that conversation eventually as well, that the stories of the Bible and the science go hand in hand. And I think this is demonstrably false. And look, I think we're all, to some degree, motivated by our intuitions and biases on some root level. But I think there's a difference in the way that I think people with a scientific perspective and people with a religious perspective navigate that reality. Because I might have certain intuitions, but I'm far, I think, more willing to abandon a point of view when it's been demonstrated to be inconsistent or problematic or false. And I'm not convinced that that's the case when it comes to the religious perspective. I don't see that. Now, of course, I'm not in your head. Like, I'm not claiming to know one way or another, but this is just my impression that there seems to me to be motivated reasoning of a different level. I think that if the theory of evolution was expressing what you've described, we would all be in agreement. My claim here is that that's not what's happening. I don't think that your understanding of evolution is accurate, that you are creating a picture of what the theory suggests that is very divorced from what's actually being said. I think there is a ton of evidence, not just in one field of science, but in several. And I think that it's strange to me that you would view scientific observation as just being what we can observe with our own eyes in that moment, when much of what we do in science is actually put the pieces together as to what happened and the mechanisms of what happened. Like we said earlier, like we don't observe black holes, but we observe the effects that it's had on things that I just think that there is a fundamental misunderstanding of how science operates. And I think this is part of the problem, why I think we're talking passage to some degree. I would be definitely open to continuing this conversation and maybe getting into, like you were saying, the weeds of it and more detail as to maybe to see where these misconceptions lie on either side. I think I'll leave it there. I would stay longer, but I am starving. I haven't eaten anything all day, and it's almost 9. I got busy earlier today, and I haven't had a chance to eat anything. So,
Oh, you're good.
Yeah, man, I got you.
Yeah,
Yeah.
Good.
but I I appreciate everybody that came, on the panel that came on today, and I appreciate everybody in the audience that listened to this conversation. Here's something I want to post. Watch Aaron Ra's videos to get a better understanding about some of the things you brought up. And
I've
that's the other thing I want
watched
to say, actually, before I
I've
forget,
watched them all.
is I don't consider much of the Bible to be historical. I think some of it is. I think a lot of it is metaphorical. I think a lot of it is mythology. There are historical aspects to the Bible, but to view it through the lens of any kind of science book.
It's not a science book.
Okay.
Yeah, it's not a science book. And I just said Genesis is historical narrative. Yeah, the Psalms are poetry. Revelation is apocalyptic prophecy. Yeah, and then, Romans, 1 Corinthians, that's epistle. Yeah, so they're different genres. You don't take them all the same way. But that's the big thing, is we believe Genesis is history.
And I would say, just to point this out, is that kind of my concerns about your interpretations are being echoed to some degree in the comments. Now, I know that a lot of the people watching this probably are on the non-religious side anyway, but I think
we're used to it.
They strawman and lay gigantic mistakes of science when laying their claims. This is how I feel, but I don't think that look. I talk to religious people on a daily basis, and a lot of the religious people that I engage with, I do think are coming from a disingenuous place. I don't think that either of you are, and if I believed otherwise, I would say so. I just
Thanks, man.
So I think you're not being disingenuous. I just think
Disagree.
you're confused. Like, not to be an asshole, but like that's my perception. I think that you are
That's okay.
confused about what the facts are.
So let's get into, like, you know, we'll let you go eat, but let's schedule this out so we can go into each specific category amongst this, and then
Perfect.
you know, we'll make this a series, man.
Sounds good to me. That
Okay,
sounds good.
I'm down
That
for
would
it.
be fun.
That would
Yeah,
be fun.
okay.
That would be
All right,
fun.
guys. Thanks again, everybody, for having joined us. And
Thanks for having me.
absolutely, thank you so much for coming.
Thanks for
Bye.
having us.
And
Thanks
Yeah.
again.
I will be back with some more content later this week. So thank you.